So, just like to introduce our topic of industrial minerals, and we have two speakers today. The first speaker will be Julius Marinelli of National Geologist for Brickworks Limited, who will speak on some factors in the exploration for brick, clay and shale. Julius is an exploration geologist with over 30 years experience in exploration for most commodities except coal and iron ore. That's not a shame, really. Might offend a few people there. He is a graduate with honours in economic geology from the University of New England and has worked in just about all Australian states and territories. He has worked for majors including CRA, Rio Tinto, Zinifex, Oz Minerals, MMG, and also worked for a series of juniors featuring Jaguar Gold and White Rock Minerals. Wherever there's been an exploration recession, Julius has moved laterally to avoid driving taxis, so he worked in oil, shale and industrial minerals as a contractor. I think now it's not just taxis anymore. There's a few other opportunities there as well. An opportunity to be a raw materials manager at Austral Bricks 5 years ago led to his current role as a national geologist with mother company Brickworks, where he applies his exploration trade for Australia, for the Australian and occasionally US operations, all the while learning the eccentricities of brick manufacturing. I'm sure Julius might expand on that one. Our second speaker is David Hamdorf from the GSWA, and he'll be talking on the Metallurgical Silica, WA Silica Sand resources. David is a geology graduate from the University of Tasmania from an embarrassing long time ago by his own admission. He's based in Perth since the 90s, where his career has taken him from boots on the ground exploration role with CRA to geoscience data management and resource modelling, through to his current public sector role with the Department of Mines, Industry, Regulation and Safety. His work includes taking him to some very large deposits, including the Broken Hill mine in New South Wales, Honeymoon Well nickel in WA, and I'm going to get this wrong, Kventveld REE uranium in Greenland, as well as smaller mines including manganese at Woody Woody. I don't ever want to go to the Great Sandy Desert again. Lithium at Mount Catlin and gold at Kirkalocka. David's current role in government is in the Land Use Planning Branch, which is part of the GSWA. The Land Use Planning Branch provides advice on government policy and approvals for managing the interactions between land tenure changes and the state's interest in maintaining land open for mining. The question of land open for mining can be a busy area around the margins of urban expansion, where it comes into conflict with the extraction of construction materials such as sand, gravel and hard rock aggregate. I'd now like to ask Julius to start his presentation, and then David, and we'll save all the questions to the end. Thanks, Julius.
Thank you very much, Peter, and thanks to AIG members and non-members who are viewing this today, and hopefully I can shed a little bit of light on something I've been involved in for 5 years. And it's been quite interesting and different to a lot of the work I've done in the past. So here we go. That's all working, just a general disclaimer, and it's good to have that there just in case. Right, now, what do you think inspired the building on the right from the 2750 BC wall on the left, which is, some say, the oldest remaining brick structure on Earth. It's on the banks of the Nile. In central Egypt, and you can see on the right that it would have taken the brickies quite a bit to do that, but that's a design by Frank Gehry, a famous architect from the US. I think that's the only building design that he's accomplished in Australia. But anyway, I'll move on. So I'll just have a quick outline. This is a pretty quick presentation. History, we'll explain clay and shale from our point of view, how we do the mixes, very brief note on manufacturing, a little bit more on exploration and what we turn our sites into at the end of their working life, and just a quick summary. So bricks have been known for about 7,000 years. Southern Turkey and Jericho are the areas where they come from. People used to use mud bricks to start with, but then developed with, I guess, wood-fired kilns. The Romans tended to differentiate between the sun-dried bricks and the kiln-fired bricks. So And they did a lot of innovation, like, stamping of the bricks with their own brand on there. Like you might have seen some of the old bricks around the first settlement areas in Sydney, where there's an interesting stamp on the bricks. The Romans also developed mobile kilns, so they spread the bricks throughout Europe as they were conquering different areas, and so they moved along. And to the modern day, we've got machinery, all sorts of earth-moving equipment. Just the productivity has increased so much to the detriment of large numbers of people who are employed in brick factories. You might see some movies on YouTube where you see dozens and dozens of people handling bricks manually, but these days we have a lot of robots inside brick plants, and several dozen people will work in a brick factory versus hundreds back in history. So bricks mainly made from shale and clay, but there's also inerts like some feldspars, which just help to sinter the bricks and help the materials all to combine at the appropriate temperatures. The bricks are clay bricks, mainly the extruded ones, which we specialise in Queensland, and a lot of this talk is about my experiences in Queensland. And also there's dry pressed bricks in Sydney, and other companies and around the world might make bricks from fairly soft mud. Definitions. You basically need the three components. As I said, clay is weathered rock plus a bit of moisture, about 10% moisture, and 2 microns. The important clays for us are kaolin, which is like a measured shrinking clay. It doesn't shrink too much, but it's predictable. Also, illite is a good material. It's mica-like clay. What we don't like are the smectites and montmorillonites, which can get into your brick mix if you don't do your testing early, and the result of that is either cracking in the bricks or actually exploding in the kiln, which can cause a lot of drama and shutting down your operation and then cleaning it all out and then firing it up again. But luckily that doesn't happen too often. The second component, shale, it's a general term used by brick manufacturers, but most geos know, shale is also a grab bag term, but it's basically, in clays, muds, silts. Again, they have, you hope dominantly they are with kaolinite and a bit of illite, and you don't want the swelling clays in that. Inerts can be, sandstones, even some volcanics ground up if you're lucky enough to get that from other sources. And also we actually recycle bricks. Sometimes those bricks that I mentioned earlier that may crack or they're not good enough to sell, or they go back into the mix and get ground up back in the crusher. And you can get several % of that material to go back into the mix. So an image there on the left is a cut through our Ford Road quarry near Rochdale, and you can see a little bit of a weathering profile, and then into a mottled clay, which tends to fire to a light colour. And we like the lighter coloured clays. The public seems to like those. And you can see the buttons there. We fire buttons. We make 50mm diameter buttons as our first test, and then you can do all the measurements. We run them through the kiln, and we don't use those 1 hour kilns, which, or we do have them, but we don't. We like to run them through our kiln on site, which takes about 2.5 days to go through. So there are measurements like a drying shrinkage. These are all sort of linear measurements. Firing shrinkage, which is up to over your 900-degree mark. The colours are absolutely important. Loss on ignition as well. See how much of your waters are removed. And interesting one is cold water absorption, which is you get a brick and you put it in water for 24 hours and you weigh it. So weighed dry, weighed wet. And if it absorbs more than 10 or 12%, then that's not quite the right brick. It doesn't have an exposure grade. So when it rains, if your bricks swell and then drying, they shrink. Doing that several times would be like, you know, weathering of rocks. So you don't want that. You want a nice brick that will last you a long time. That shale on the bottom there, you can see the colour. It's very dark, and again, it helps us to make some of our darker brown or red bricks. Of course, the geology. This is a local area here at Rochdale, and that sort of middle green unit that I'm pointing at is where our pits are. It's quite significant amount of clays here, but unfortunately, through you know, residential development, there's very little of it available. So we have, and I'll show you shortly, the quarries that we operate from. This geology is part of the Ipswich coal basin. You tend to find just about anywhere else, anywhere in the world, that if you have like coal or carbonaceous sediments where they weather, they will form a reasonably good clay, and that's what you look for when you're doing exploration for clay. Here's some images of our quarries here, or our pits in southeast Queensland. The home quarry with the factory in the northeast corner, that's our Rochdale pit. It's been here for over 60 years. So we've got very little left in terms of resource, but we do have enough for another 10 years or so. And also we have where we mix our stockpiles, which I'll talk about shortly. We use that as our mixing area, and the crusher is near the factory, and the process continues. Ford Road is about 7 k's away on the right, and German Church Road Quarry is about 20 k's to the southeast. We get most of our material from those pits, but we do get some opportunistic developments, you know, like building sites, large unit developments where they need an underground car park. Often you find there's a good 6, 7, 8 metres of clay there, and we can actually take that. You know, we do environmental testing, but we can offset some of the consumption of our main pits with the material from other sources. You know, some large developments, even road widening. Recently, our large M1 to M3 road widening material was offered to us, and we gladly accepted it after testing. It proved that we could use it. And also currently in Brisbane, we're going through the Cross River Rail Tunnel development, and that material, some of that material can vary from shales to even volcanics, and that tunnelling machine can crunch up the volcanic rock to a fine powder, and we're currently testing that to see if we can make bricks out of it. Quick rundown of making stockpiles. So you get the different raw materials. We have 4 basic mixes, which are the body of the brick. If you ever pick up a brick, you can see the body of it, not from the face, but you know, over the top underneath. And then from there, you use different techniques to scalp the brick, or put a pattern on it, or spray it with a slurry, which then hardens and gives it a glaze. So stockpiles are built with those materials. We have up to 15, 16 materials on site from different sources, including our own quarries. That's a pretty ugly stockpile, but you can see some of the carbonaceous shales in there, but mixed in with the lighter coloured cream clays. And also we get those materials, and with testing we get the proportions that we like to give us those creams or those buff colours, and then they're mixed on the floor of the pit by a very large bucket loader. It's mixed a bit like making a cake, and then that material is then transported to the crusher, where it's crushed down to minus 10 or so mil, and then from there they will be put into the clay shed, and then from the clay shed put through the grinding process, which is then the start of addition of moisture to get your green brick, and then it gets fired to a fire brick. So, so the first part of my talk's been the top half of that diagram. So we got to the clay shed. I won't go into the manufacture process, because that would probably take another 15, 20 minutes. But basically, the material is ground down to very fine, 1 to 2 mil, and then water is added, then it's formed, and then dried in kilns, drying kilns up around that 100-degree mark for about 24 to 36 hours. Then it goes straight to the 160-metre long kiln, which uses gas, and then at the end, robots will unpack the material and put it onto shapes in pallets. And the unpacking is done in a way to blend all the bricks, because some bricks are slightly different colour from the top of the kiln to the bottom, and then that's how you get your blending. And in other ways, you can manipulate the kiln so you can get complete consistent colour all the way through. So just some quick stats. Bricks weigh up to 3 kilograms. Obviously, a pressed brick is a solid brick, so it's just about 4.5 k's. You can see the pattern here where the cores are there, and that they're designed to have the hot gas flowing through and baking the brick or firing it very well. Roughly about 8,500 bricks to a house, and at Rochedale we process over 200,000 tonnes of clay and shale per annum, and we pay the government a royalty, so that money goes towards schools, hospitals, police, as you hear the politicians say. So we make a contribution. Now, to area selection, there's a little bit of that green material there with quaternary in the centre there. They're the sort of areas we look at. The Triassic age rocks are nicely weathered, but we can also use some of the quaternary clays that have been washed down, the last 100,000 years or so. But they tend to be very plastic. So if we can find an area where there's a variety of clays and the shales underneath, then that could be a good candidate for in future for building a quarry, or if the distance is okay, we can transport that material back to the home factory. We like flat ground or some slight undulations, but we don't like hilly country. Then, if we see those areas are good enough, we apply for tenement, and then because we're exploring closer to metropolitan areas, we have some barriers, or so much barriers, but we have to be careful how we work around strategic cropping land, living areas, comfortable living areas. Some of the government zones are that, and also very conscious of the environment as well. There's council zoning, which will let you extract or maybe not. Then we also target, because we want to eventually own the land that if we find a deposit on, then 100-acre blocks or greater will have enough material at 7 to 10 metres thickness to supply around that 10 to 20 million tonnes we need to have a resource that will take us forward 40 years. So you have a good, decent, build a factory, which is not cheap, and then you use that factory for all those 40 years. And but some of the challenges we have are, people now don't want pits or quarries in their backyard. So we have to be delicate in our negotiations and explain to people why we're doing the exploration, and eventually, hence we would like to own our own land. It's ironic that a lot of the people on the fringes of cities do have brick houses, but they don't want a brick pit beside their house. So, for instance, in southeast Queensland, there's still a lot of good land that's got clay underneath, but it's being developed now. Market gardens are being dispersed, but because the developments are shallow, they're not deep enough for us to get into the really good clay. But we live in hope. Just another factor is the valuation of land. So if we want to purchase the land, you can see from this table changes in valuation in Sydney, for instance. It's quite significant, and that's a big factor in working out whether we actually want to go in that area apart from the land access. So on the right, there's a couple of areas there that you can show the filtering process, and there's a couple of blocks there that meet that plus 100 hectare size, and then we move on from there and negotiate if the people are willing. Of course, exploration, it's most of it is standard exploration, shallow drilling. You don't really need to drill more than 25, 30 meters down, because a lot of the pits are no more than 10 to 20 meters deep. But small rig, you can either get a coring rig or a air core rig, which is pretty good and takes samples at a meter. You can see the change in lithology from the weathering, and the material tends to be pretty good in the top 10 to 15 meters, and then some of the fresher material is usable in the shale component. Some of it has a little bit of carbonaceous matter, which it also helps the firing process. But other than that, that's pretty much the base of the pit. And then, but with coring, you can see we can take good sticks of core and fire the individual pieces to show you that's the fresh rock and that's what colour that comes out. And also we do our buttons from the air core or RAB work. Also, in terms of trying some innovation, I approached a consultant in South Africa and asked him if he could pick some clay from 700 k's above the earth, and he's given me some interesting material. Montmorillonite, which we see as a swelling clay, is actually not a bad pathfinder for kaolinite, as it's quite a bit of montmorillonite in the Ipswich coal basin, but with a lot of weathering and over time, it does leave a little bit of residual montmorillonite, and that seems to be where it's concentrated. You can potentially find some clay underneath, or kaolinite clay. This site here was found by PGH Bricks back in the early 70s, but because of pressures from the community, this development never took off. But as you can see from this scene, which was taken a few years ago, was processed, and you can see that nice big anomaly on the top right-hand side of that image. There's our Ford Road pit there, so you can see that we're continuing to exploit that heading down in the mining lease. So I consider montmorillonite from space not a bad pathfinder. And you also can get a 60 by 60 kilometre footprint, so using it for tenement access, or even to determine an area where you can take tenement, you can use that, and as I say, you can cut the good pasture from the bad in terms of finding clay. Also, we've been trying this loop TEM, or transient electromagnetics, in Perth. It's being developed at the moment. Tried it on our Carter pit, or beside the pit in WA. We already had some drilling information, and it took the operators about half a day to traverse north and south along those the drilling lines, and some of the results have been quite encouraging. So with resistivity, you're looking for more sort of, or less resistive, more conductive, which tends to be what shales and clays do. And that's a tilted image, but it certainly sort of mirrors what that looks like. And also you do your look at your north-south cross sections, and you might be able to trace the changes in your lithologies. And that's the aim, is to use that technique, or in the future, to try to minimise drilling, because a lot of people close to cities don't like to see drill rigs in the paddocks or in their backyard. So we hope that if we can use this technique and talk to landholders, then we can use it, and then just do some much less drilling to confirm what is there. So it's still an emerging technique, and there will be an AIG paper out hopefully this year on that. So and one of the other things that's quite interesting with with what we do is the rehabilitation. Now, most if you're out out of Kalgoorlie or Bowen Basin, what do you do with your pits? But we, being close to the city, we can take advantage of potential developments, and we're turning exhausted pits into good value real estate, commercial and industrial, and building warehouses. It's becoming quite the thing to with the way society we're buying things online. So recently, Amazon signed a deal with Brickworks Goodman partnership to build a 10-story robotic factory warehouse. So and that's a potentially 20-year leases, and that will continue the use of that land from when it was a pit a little earlier. So and it's a win-win. So there's employment created, and for that acreage or hectareage of land, there will still be value continued over a long period of time, and it's good for the company shareholders as well. And there's an image of what that building will look like in a short time. So summing up, bricks are, essential. People are still buying them. We're making many more varieties and colours and shades and shapes. And but one of our challenges is the access to get more of this material, so that the next several generations can take advantage of the maintenance-free, the non-painting, the weatherproof, and the guarantee of 100 years of bricks. And also, we're using innovation to, in the manufacturing process, sustainability, using less energy per brick, and also using a bit of innovation to explore for clays on the outskirts of cities and a little bit further out. So that will conclude my talk. I've just got a couple of quotes here from various writers about clay, and the furnace which melts gold also hardens clay. So before blaming thy fate, therefore find whether thou art gold or clay. So thank you very much for your attention, and I'll hand back to Peter and David. Thank you.
Thanks very much, Julius. If anyone has any questions for Julius, please get them down on that Q&A panel, and we'll get to them in the end. I'd now like to call upon David to give his presentation. Thanks, David.
Okay, thanks, Peter. So let's just bear with me while I try and get mine up. Okay, is anybody seeing that yet?
No, we're still on Julius's. Julius, can you stop sharing yours, please?
Sorry.
You should be good to go there, Julius.
How does that look now?
Thanks, David. Perfect.
Okay, so something about my background. So I work in the land use planning branch in the Department of Mines, and that is primarily a group that deals with changing land tenure of the state's crown lands to private land, either crown land being purchased or crown land being leased, which mostly affects the regional areas. But we also have a role in formulating government policy to make sure that access to construction materials is still possible as the urban expansion continues on ever outwards. So that's probably what brings me into the area of talking about sand and clay and gravel. Now, rather than sort of talk just about the very essential part of the modern economy, which is what makes up bricks and roads and gravel for roads as well, I thought I'd talk about silica sand. So that's something a little bit more unique to Western Australia. So in Western Australia, we have an area called the Bassendean Sands that are some of the most infertile soils in the world. And they're mostly comprised of sand, a little bit of clay, minute amount of carbonate, and minute amount of heavy minerals. So some of those sands in the Bassendean Sands are getting up to 99% pure silicon dioxide, which starts to put you up in the realm of material that can be used for making glass for windows, or in the modern world now as feedstock for getting silicon to make solar panels. So once upon a time, sand in Western Australia, you might have been getting about $5 a tonne for sand used for concrete sand. Silica sand is getting up anecdotally to close to $100 a tonne. So if you think that mining sand is not much more difficult than scraping the vegetation off, picking a front end loader in to dig up that white sand, screen it, truck it, that becomes a pretty attractive value proposition for anybody that is thinking about getting into the silica sand business. Not as simple as it sounds. The economics are quite compelling, but land access is a very, very definite part of getting to the West Australian silica sand business. So anyway, that's why I call it metallurgical silica as opposed to just silica for glass making. And we also have a silicon metal refining business in West Australia run by Simcoe, which has a state agreement smelting site south of Perth where they smelt quartzite to make silicon metal. And that's sourced from a quarry of very pure quartzite north of Perth. And that quartzite quarry again runs about 99.3% pure silicon or silica dioxide. So that's why I say a little bit about Simcoe's business, but mostly about silica sand. So the difference between silica, as we all should know as geologists, is it's silicon dioxide, whereas the material that Simcoe refines is silicon metal, which is that semi-metal in the periodic table, quite shiny but brittle. And it is definitely one of the essential materials now for the new energy age as we're going into progressively large amounts of solar panels being rolled out around the world. So for those not familiar with Western Australia, we're mostly focused on what we call the Swan coastal plain, which is running along the western side of Western Australia. It's the area on top of the Perth Basin where, when Antarctica in India and Australia rifted apart with the breakup of Gondwana land, when India rifted away from Western Australia, the Swan coastal plain is formed on top of the Perth Basin, which is the infill over that rift zone. So east of the Swan coastal plain, you've got the large area of the Yilgarn, Craton, granites and gneisses of Archean age, whereas the Swan coastal plain is probably mostly less than 10 to 5 million years old. That is top. So zooming in from what we can see on satellite imagery, the Darling Range and the Darling Scarp is quite a pronounced transition in colour. So on the Darling Scarp, a lot of the old growth jarrah forest, most of that is under protection from clearing, and it is still largely pristine jarrah forest, but there is also some bauxite mining there. Yellow dot for Kemerton's silicon metal smelter south of Perth. There is a dot in the middle, which is the area we're going to be talking about for the Bassendean sands and the sand dunes we're going to be looking at in a bit more detail. And the northernmost yellow dot is where Simcoe have their quartzite quarry, where they are quarrying very pure quartzite, 99%, 99.3% silicon dioxide. So this is taken from Simcoe's website. So if you'd like to know some more about Simcoe, I've put their website address up there. What is different for Simcoe is they are using lump quartzite. So this is a very standard carbothermic reaction. Lump material is mixed with a source of carbon, in this case, charcoal from wood, heated up, and once the temperature gets high enough, there's just a chemical reduction of the carbon onto the silicon dioxide, and that produces molten silicon metal. And that silicon metal is then cast into ingots. Now, I think for the solar panel industry, that silicon metal still has to go through a few more refining phases before it's at the purity that it's ready for forming into solar panels. So now we're switching to a view of the Swan coastal plain really what you can see in Google Earth. So we're not talking anything very sophisticated here in terms of remote sensing. Today, we all take this for granted. If you could go back to the era when Julius and myself started working as field geologists, mostly all we had to work with were air photos and maybe some Landsat. So there's nothing in the exploration for surface materials that you can't be doing with air photos in any country around the world without ever needing to use remote sensing. But nowadays, remote sensing at very high resolutions is available essentially for free. So we're going to just see a few more images just coming out of Google Earth. So we're looking at the area, middle of the screen is the Perth CBD showing up as the light area. I've put a comment out there in the blue sea for Rotto, which is Rottnest Island. There's some orange arrows pointing to where the bauxite mining has been happening on the Darling Range, and that's where we have a very deeply weathering profile over both granites and dolerites. Essentially, that has removed almost all the silica and the iron, and you're left with, alumina oxide. A similar sort of process happens on the Swan coastal plains for some of the sands, where in the more recent last 5 to 10 million years, some of the residual heavy minerals in the sand have been leached out by rain, really just leaving silica sand as the only component of those areas. A bit more about the Swan coastal plain. There is a ridge of sand dunes runs along the coast that's named after the suburb of Spearwood. And to the north of Perth, where the suburb of Bassendean are, is also the area where we have these incredibly infertile sandy soils. And those very infertile sandy soils have given rise to the Banksia woodlands that are quite unique to Western Australia. And they're also regarded as areas of substantial biodiversity values by the Commonwealth Government. So they have some very definite access issues around that. So you can't untangle the unique geology from the unique flora and fauna. So what I'll put up now is a sun-shaded digital terrain model. It makes it much easier to see the topographic relief. If you were a geologist working with the old analog technologies we used to work with, you would have your air photos out, a stereo pair of air photos, looking at those to determine where those sand ridges were. But nowadays, good quality digital terrain model is available for use in whatever software you like. QGIS, making sun-shaded images, is a really neat way of showing up very subtle types of topographic relief. So I've got Rottnest Island shown as a reference point, CBD as a reference point. We're going to be looking at some images north of there, so it'd be good to keep in mind those marker points, just so we keep our frame of reference in mind. The Spearwood Dunes is that very prominent ridge that runs along the coast, and we see that ridge both south of Perth and north of Perth. That is primarily sand with a very substantial part of carbonate from shells. So the evolution of the Swan coastal plain, there hasn't been a great deal of active erosion off the Darling Scarp. Most of the sands that we see on the Swan coastal plain and the Perth Basin are believed to have been transported from the Gascoyne area down the western edge of the Yilgarn, mostly by wave and sort of current. So it's probably at the stage now with the very mature environment we have that most of the new material being deposited on the current day coastline is largely carbonate from shell fragments that are being washed onto the beaches, and from the beaches being transported by wind onto the Spearwood dune system. But when you look at the detail of the Swan coastal plain, clearly it has had its times when it has been flooded, and the Bassendean dune formation on that seems to be part of that flooding event as well. So a very different mode of formation to the Spearwood dunes. So we're now looking at the Swan coastal plain. I've got Rottnest Island as a marker point for our reference on the bottom left-hand corner of the screen, a star on the CBD. And there's a series of yellow arrows around a grey area, and that is primarily the area where the Bassendean sands are occurring. The dune system along the coast makes quite an attractive area for real estate development. People can build their houses on top of that and have a nice outlook over the sea. So over time, the Spearwood dune system is not really a very attractive option for getting construction materials from, largely because of that tension between where people like to live and where is a good source of construction materials tend to occur in the same place. And at the time being, you know, an outlook over the ocean is probably going to win out over maintaining land available for quarrying for construction materials. So again, we're going back to looking at that sun-shaded DEM from LiDAR information. The Spearwood dune system becomes a very prominent feature that you can see in that sun-shaded digital terrain model. And as I said before, it has a very substantial component of calcium carbonate, mostly from shale fragments. And some of that evolution of the Spearwood dunes tends to be that as lighter silica is blown off those dunes, there's an accumulation of calcium carbonate on the eastern side of those dunes, and we do tend to get quite high quality limestone formation there. That's an attractive building material in its own right. And if you look at some of the historic buildings around Perth, they're clad in a very attractive biscuit coloured limestone, and that tends to come out of the Spearwood dune systems from what is the Tamala limestone. The base of the Darling Scarp's a really obvious feature, and then you've got quite a different texture on the upland areas, which is granite and gneiss. Now, if you're a company looking for clay for bricks, along the base of the Darling Scarp is where you have some plastic clays where there are shales present, or there is alluvial clay formed at the base of the river systems that drain through the Darling Scarp and then onto the Swan coastal plain. But that's a story for our brick friends. So we're going to be looking at two focus areas. There are both shown as B. There's a number 1 and a number 2. The number 1 area is where we're going to look at a current area of sand quarrying. The number 2 area is a current exploration area, and I'm not going to mention the company's name, but for people that like to Google these things up, I'm sure you'll be able to work out which company it is. So we're now looking at that first case study area. It's known as the Nungara Sand Quarry. It is in an area of what we call state forest, which was once upon a time Banksia woodland, but that was cleared for radiata pine plantations. So the amount of woodland that is now left is becoming, you know, an issue. So bear in mind when we're talking about these quarries around Perth, we're also talking about an interaction between a desire to preserve those Banksia woodlands as well as maintain, you know, essential sources of construction materials for the Perth environment. And most houses in Perth are built on sand pads. So between up to 5 million tonnes or more of sand is used purely for forming sand pads on new construction sites. So it's not as exciting as a hard rock gold operation, but the volumes of material being moved around the Swan coastal plain, probably in terms of volume at least, they're up there with a medium size or larger hard rock gold mine. But we don't really think about mining on the Perth Swan plain, but it's definitely there. So as a reference for scale, I've got a yellow bar about 3 kilometres long. We're going to look at, the next image is going to be simply what that looks like in Google Earth. You can sort of see what looks like agricultural land to the south and west of that screen. That was Banksia woodland, but it was cleared of the Banksias and radiata pines were put in there by the Forest Products Commission. The suburb of Ellenbrook, very obviously to the east of that road. And we've got that area where one of those old dune systems from the Bassentine dunes was pegged under mining lease applications probably about a good 30 years ago, and that has maintained access to that land ever since under Gryton mining lease. We're going to take a little bit of a view into that zoom in area and have a little bit of a discussion about what those colours mean between yellows and whites. So it's not as simple to say that all of the Bassentine sand is high-grade pure silica sand. A very large part of that has still got a small amount of iron in it. And I've got a pointer showing where there's a subtle colour change from whites to yellow. So that yellow sand, that's a very typical colour of sand that is used on sand pads around Perth. Depending on the amount of clay and other impurities in that sand, much of that sand is also used for making concrete. The silica sand tends to be a bit like the icing on a cupcake. It's where the most leaching of residual minerals has taken place from rainwater action. And so when people are talking about silica sand as a concept for the Bassendean dunes north of Perth, mostly what they're thinking about is removing the top 50 centimetres of vegetation or organic matter, and they're looking at then scooping off the first maybe 2, 3, 5 metres of sand that is the very high purity silica sand, or certainly the silica sand that's got the least impurities. But underneath those top few metres, particularly if you're mining one of these old dune systems, almost all of that material can be used for some type of construction activity. Fill sand is probably used in its greatest volume, but it's a pretty marginal profit operation for the construction material companies. Fill sand might be going between sort of, $2 to $3 per tonne, and the transport costs are a significant margin that eats into any profit. And if you're trying to take fill sand from the Nungara pine plantations and truck that 100 kilometres south of Perth, it's doubtful that you could really make any money out of that. The bulk of the money that is made out of sand mining is from the concrete sand. And if you have silica sand, then that's certainly the icing on the cake. So again, this is a quarrying operation that is owned by one of the large construction companies. Again, I'm not going to mention their names, but anybody that's really interested can research that on our GeoView and 10-graph system. If we think about what makes up a typical sand quarry, there is a very nice modern site office right at the bottom of that screen. And in the middle of the screen is where there's a screening and washing and blending operation. So this sand quarry makes quite a few different products. Some of the basic output is plaster sand. Some of that basic output is construction sand, but they also do produce, very nice, clean, white-washed sands that are used for playgrounds and gardens. Whether that is more profitable than putting it in a truck and onto a boat than setting it off to be refined, I don't know. But really, the pure white silica sand is not necessarily the largest volume produced out of this site, but it does have a significant profit margin attached to it. So it's something to bear in mind. Now we're going to go up to the current exploration play, as I call it. I won't mention the company's name, but if we look at that sun-shaded DTM, you can see that, to my eye at least, you'd look at the distribution of sand dunes and think, really that does look like ripple marks on a beach or ripple marks of sand under the water very close to the high water mark. The area we're looking at now is actually on top of carbonate rocks. It looks pretty likely that this area of the Bassendean Sands at some stage was almost a shallow sea pre-ice age. And as the seas have receded off the Swan coastal plain, after initially having been sort of, reworked by water to leave you with mostly silica, there hasn't been that input of seashore fragments to form those lime sands that are very distinctive of the spearwood sands. So this is an area that's probably been reworked sands probably 1 to 2 million years ago. And with the changing environment in Western Australia from who knows what it was before the Ice Age, potentially tropical, through to the very dry time of the Ice Age, the top few meters of that sand is absolutely stripped clean of just about any other mineral component other than silica. So these are dazzling white sands when you go out there into the Banksia woodlands, extraordinarily devoid of minerals for vegetation. That's why the Banksias are a very phosphorus intolerant plant species. So if you were to put a handful of garden fertilizer onto a Banksia, it would drop dead in a few weeks. I mean, these plants are by evolution adapted to growing on soils with almost no mineral component to them. So we've swapped over now to the Google Earth view of the world, and you can see that the agricultural land runs along the base of the Darling Scarp, but then you swap to an area to the west that is just all that very dark grey coloured area, which is all Banksy woodlands, and a little bit of that white is starting to creep through. So if we think about where JORC is going at the moment and materiality, this is probably an area where I'd say for anybody that is wanting to report this to the stock exchange as a competent person, maybe you need to be putting your hat on and thinking about the ESG factors and saying, perhaps there's something here that I should be researching further for myself as a geologist in terms of some things we might need to know about. So one of these is land tenure. So land tenure is probably, one of my specialty areas. So again, all this information is out there in the public domain for any geologist or mining engineer or tenement consultant that would like to look this up. This is a mosaic of land that is state forest. There's a mosaic of land that is under reservation for conservation. And there is, in the green, the area that is unallocated Crown land, which in the normal scheme of things would be land that has the fewest impediments to access. But I've put a yellow comment there that land tenure matters. And we're going to now look at something that not many geologists have really switched onto yet in Western Australia. So in Western Australia, we have a government service called TenGraph, which is to make all Mining Act tenements freely available to the public through an online web app run off the Department of Mines website. It has a companion product called GeoView, which also shows much of the same information. And we have something that we call a file notation area in our tenement information. Now, a file notation area is not a Mining Act tenement. It really is just a set of spatial data that is publicising government proposals. So if there's a sort of a final closing comment I'd make about this area of unallocated Crown land, which is subject to a current exploration play, it would be good to do your homework, check the file notation areas and see if there's any other conflicting government proposal that might impact on your land access. And in this case, there is a file notation area, and that's popping up as that crosshatched red area overlaying most of the unallocated Crown land. So putting my JORC hat on, I would say first appearances are that this unallocated Crown land would be prime exploration ground, but do your homework, check the other public information that's available, and you'd find that what is most of your potential geological resource has actually got some land access impediments likely to happen in the future. So if there was some homework that I'd ask people to do, it would be to have a look at the Department of Mines website, find out where the TenGraph and GeoView online systems are, and do some browsing around and try and understand what a file notation area is. Because if you're working in the West Australian domain, file notation areas are very definitely something you need to be available of. So I'll sign off there and take some questions.
Thanks very much, David. Just before we go to the questions from some of our viewers here, please get your questions in shortly or presently, and we can get to them. Before we get to those questions, I tried to get some input from Geoscientists Australia on this topic, given it's something that affects all of us and that there isn't anyone in Australia who doesn't use these products in one form or another. And unfortunately, there's no one there at all who's monitoring this and can tell me how big this industry is. I take it, David, it's all been completely left to the States. Would that be correct?
Well, there is a critical minerals strategic understanding of the new technology materials, for want of a better word. It's not just the battery metals, but it's also the materials that make up the renewables. So it spans the rare earths for magnets, definitely the silica for solar panels, but it is also materials that can be used in rechargeable batteries. Lithium, as we all know, but potentially vanadium and potentially manganese. So the Critical Minerals Initiative is definitely something that the Commonwealth is involved with, and there was also a Critical Minerals Initiative in Western Australia. That by itself doesn't really change how you have to do your own homework and understand land access. Where we're needing to look at some of these materials where we know geologically there are very large supplies of these pure silica sands, it is also an area where there is very, very substantial environmental values, and environmental values that are very much part of the Commonwealth's legislation, protective environment as well. So access to these materials is absolutely requiring you to have an understanding of the current land tenure and potentially the future land tenure. So you do need to navigate the EPBC Act. Is there an appetite to review the EPBC Act and the State-Based Environmental Protection Act to get better access to these materials? I'd say it's always subject to lobbying from different parts of government. So government is very much different tribes. Each tribe's got its own perspective, and how this will play out, it depends on many things. We've just had a state election in West Australia that's had a resounding landslide to one political party. And there's a perception that political party is probably more inclined to be protective of the environment than making that environment available for the critical minerals. But, you know, I'm probably just expressing a personal view there.
Thank you. But I guess expanding beyond the critical minerals, this topic kind of also covers things like the clays and construction materials like aggregates and things like that as well, which tend not to be included in some of the federal work. So I guess that really is just left to the states. Do we actually know the size of these industries, or is it something that it's just construction materials, we don't care about it, and we'll just move on to things that are shinier and give us we can sell to the public?
Well, one of the quirky things about these materials in Western Australia is, by definition, on private land, a lot of these construction materials aren't classed as minerals for the Mining Act. And so permitting of these is actually done out of the local governments under their planning and development regulations. The groups that have information about this tend to be the Chamber of Mines and Energy, and there's an industry association called the Concrete Aggregates Association, I think it is. And there's certainly statistics around the production of bricks and concrete in Western Australia, but it tends to be more of interest to the planning people up in the Department of Planning, more so than regarded as a mining question. Mostly it seems to be working out for everyone, but if you were to take the strategic view of what happens in 20 years or 30 years, if Perth was to keep expanding, then it has been a part of a strategic assessment, but it's not really known well in the mining domain, but it's certainly very well known in the planning domain.
Okay, thanks, David. We've got a few questions from our attendees, and if you've got any more, please keep them coming in. First one here for Julius. Presumably, this is from Michael Lego. Presumably, sulfur content in the clay can be an issue, and I take it, expanding on that, there'd be other deleterious elements as well. And how would you deal with those, Julius?
Well, first of all, that's where your testing comes in, because something like, say, sulfur, pyrite, etc., put into a kiln at 900 plus degrees, you get probably bloated bricks, as they call it, bloating, and again, that earlier mention of exploding bricks. So it's not a very good element to have, plus the fact that, you've got to check your emissions, because we get tested for emissions as well. So it's a matter of getting your testing right at the start and hoping that that material is consistent, and also continual QA/QC of that material by our local laboratories. That's internal, and also if we have any queries, we go to external laboratories.
Okay, thanks, Julius. Expanding on that, is it a question of ruling material out rather than being able to process it and remove the deleterious stuff, or are there other ways of dealing with it?
Probably ruling the material out is probably the quickest and easiest way for us. It's a low cost commodity when you think about it. I mean, to buy it off people or to mine it, it's not like mining gold or lead, zinc, whatever. But so we'd probably say, no, we can't deal with this. We'll move on to the next one. Right. But that earlier testing plus drilling in some of the older resources, that's where the consistency came in. And as I said, the home quarry is over 60 years old, but it's just about used up its useful life. But as I said, there's another 10 years material there, but 10 years in 60 is a small proportion, but it's still material that we can use and we can blend. So there's a blending issue as well. If you can use 5% of the material that maybe is still good, but there's a bit of sulfur in there, you dilute it and put it together in a mix, and it comes up with a good product, then and the emissions are fine, then you can do it that way. So bleeding it in, but generally, if it's too difficult, we'll walk away.
Okay. Considering it's been mentioned by both yourself and David with competing land use, and they're not in my backyard, and finding it, having to go further and further afield to get deposits, which then obviously the economics can rule things out. Is it worth, or has there been work done on maybe upgrading material or being able to remove some of these deleterious materials?
We've got a research unit that does look at those sorts of things, but you're right. The challenges are there. When you get to haulage rates of 25, 30 kilometres, the cost benefit is certainly on the boundary. So, but if you look at them, David might know this, in WA, some of our clays we can transport over 100 kilometres, but transport rates seem to be cheaper in the Western state than in Western Australia than in the Eastern states. So whether it's a function of the mining industry being more active there, and there's just more contractors, more competition, that's a big factor.
Okay. Yeah, I mean, when you're looking at clay in Western Australia, particularly on the western side of the Darling Range, bearing in mind most of the Perth Basin is sand, and most of the weathering profile on top of granite and granitic gneisses tends to be kaolinitic. Clay-rich materials are not particularly common in the vicinity of Perth. Where we do have them, they tend to have been alluvial clays formed on the river outwash, where drainage has cut across the Darling Scarp and deposited clays generally around the base of the Darling Scarp and about 2 to 3 kilometres out. And there's not very many of those alluvial systems. They tend to be very attractive areas for real estate and agriculture as well. And it brings us back to that central problem that, the areas that are prime sources of construction materials either have very sensitive environmental aspects around them, or they're very attractive areas for residential real estate.
Thanks, Dave. We've got a question from David McD. He says, Dave, nice tutorial. Your Bassendean Sands example under tenure. What species was the FNA noted for in this case?
Okay, so that is for the Banksia woodlands. So the Banksia woodlands are recognised as a matter of national environmental significance by the Commonwealth environmental people. And that brings it into the realm of the Environmental Protection and Biodiversity Act. So it's not just for the Banksia tree itself. That environment is also host to the endangered Carnaby's cockatoos. So the Carnaby cockatoos is very reliant on the Banksia woodlands for its foraging environment.
Okay, thank you. We've got one last question from S. Bolath. Thank you, Julius, for the interesting talk. Since the type of clay minerals is important, is ongoing mineralogical testing throughout production necessary, and to what extent is it exercised?
We do occasionally use external XRD, or X-ray diffraction, and also keep an eye on the whole analysis of the clays and shales. But it's something that I'd like to bring in a little more and actually get our own machines in-house or equipment, but cost is a factor. But slowly but surely, I'm working hard to get more mineralogy done. But brick industry's been around for a long time, so they seem to keep doing what they're doing and produce bricks that society wants. So, but a little more technology wouldn't hurt. So, yeah, I'm working on it. Thanks.
Thanks, Julius. Well, we've gone over time, so I don't want to outstay our welcome. I'd just like to thank both David and Julius for interesting talks, and certainly as a non-industrial mineral geologist, very informative and highlighting a few issues I had never considered. So thank you, David and Julius.